So all waves are made of like repeating shapes bunched together. So for example, here's like a representation of a wave. You might see each unit of the wave is going to be like this. So this is one unit because this is the smallest piece of the wave, where if you get this and then you copy and paste it onto here, onto the next part, it can get repeated. So this is what you would call one wave. This is one wave. This has a length of one wavelength. That's what it's called. And when we are talking about phases, one wave is going to correspond to one cycle. The terminology is like so because most of the time you'll be dealing with like waves that are traveling. So this whole piece of the wave will be traveling along, perhaps to, let's say, to the right. And if we are standing here and this wave goes to the right, okay, so this green line represents, like, let's say we're standing here and then we're observing that the wave is at the like 0 position. Then the wave is going to move as it passes us. So it goes down, it goes up, and then it goes back. So that's how we will see the wave continuously move if we're standing here. And when we mean by one cycle means like this one wave part, this unit of wave, have just passed us. So that's a cycle. Then when the next wave passes us, we see the same wave movement. It goes down, then up, then down, and again down and up and down. So it keeps repeating. And this basic unit of repetition is going to be called a cycle. Okay? So when we talk about one cycle, I would think of it as one wavelength. Then half a cycle will be half of a wave. So just like this chunk, this amount of wave is half a wave, because you can see it's half the whole wavelength. Then a quarter of a quarter of a cycle is going to be like a quarter of a wave, a quarter of a piece of a wave. Okay, now when we're talking about if a wave is in phase or out of phase, what we are talking about is we have two waves. One wave is, let's say, it might be like this in phase with a wave. It might be like this. It'll be out of phase. It might be like this. It'll be still rather out of phase, and so on. This is almost in phase. Now the amount that we will use to how we will quantify this in-phaseness or out-of-phaseness is to look at the length of the distance between two corresponding wave same partners. So you have to have two waves that are the same or have corresponding points. It's pretty obvious that this point and this point is pretty much like the same part of each wave. This part and this part is the same as each wave, and so on. Then the distance between here and here, well, that's some amount of wave, so that's some amount of the cycle. This is a whole length. So wavelength, we can see that from the length that this amount of length is slightly less than a quarter of a wavelength, is probably roughly a fifth of a wavelength. So we say that this wave here is 1/5 of a cycle out of phase with the other wave. Right? Now, if we want a wave to be 2 pi out of phase with this wave, okay, so 2 pi is one whole cycle if you're thinking of it in radians, so 2 pi is one whole circle. Okay, so let's look at the black line. Here, this is the wave, and we want to move it one full cycle along, or one full wavelength along here. So here, this is starting. Let's move it one wavelength this direction. So this wave is 2 pi out of sync, or well, it's already in sync now because we moved 2 pi. So it's 2 pi 2 pi radians in phase with the first. If we have this and move it half a wavelength along, half a cycle along, so that this wave is half a cycle out of phase with the original wave, is gonna look like this. So it's also pi radians out of phase with the first wave. Finally, if we want like a pi over 2 radians out of phase, so this wavelength, pi over 2 is a quarter of a whole cycle. So we move this wave a quarter cycle, a quarter wavelength along here. Right, so a wavelength is 4 units along. So this wavelength, if you want to move it 1/4 of the way, just 1 unit, according to these square grids. So these two waves are a quarter cycle, or pi over 2 radians out of phase.